we're going to talk about tree diagrams, and you've already learned about this, so this should all be review, nothing too unexpected. A tree diagram is a diagram that shows all the possible outcomes of an event. So I'm going to do an example for you. First thing we're going to do is, I have two dots. We're going to make this one a spinner. We're going to say it has 1, 2, 3, 4 pieces, and we're going to call this a quarter. And so I'm just going to put 25 cents here. Now, so if we wanted to make a tree diagram over the probability of, or all the outcomes of spinning a spinner and flipping a coin, it doesn't matter which one starts. I'm going to do my quarter first. So I'm going to put a Q up here for quarter, and I know my quarter has a heads and a tails. So if I flip a head, I can then spin a 1, or I can spin a 2, a 3, or a 4. Now, what if I flip tails? Well, I can get the same things. I can still get a 1, a 2, a 3, or a 4. So how many outcomes is that? 1, 2, 3, 4, 5, 6, 7, 8. So that gives me 8 outcomes. And it's as simple as that. Okay, so I know this is one that you're not familiar with, and that's okay because this is a new word. We're going to read it through, and then we're going to talk about a minute and see what it means. On the fundamental counting principle, it says, if you multiply the number of options from the first event and the second event, then the answer is the total number of possible outcomes. So this is like a shortcut to doing a tree diagram, or a way to check your tree diagram to see if you got the right number of outcomes. So let's talk about the tree diagram we just drew. We had our spinner, and it had 4 possible options, 1, 2, 3, and 4. Then our quarter, it had 2 options because we had heads and we had tails. So it says we are going to multiply the number of options from the first and second. So I'm going to multiply 4 times 2, and then the answer is going to give me the total possible outcomes. So 4 times 2 is 8. So 8 outcomes. Is that what I got on the last one? Yes. So this is like the way to check and see how many outcomes you would have. This is great when all you need to know is a number. But if you need to know what your options are, then you do still need to use the tree diagram. Okay, so now we're going to look at how we might actually use a tree diagram in a real world scenario, okay? So let's look at this problem. Jackie and her friends are taking a trip to Arlington for the day, and they want to make a budget. They have narrowed down their options to either Six Flags or Hurricane Harbor. They also know that their lunch options at both places are a chicken strip basket, hamburger basket, or a personal pizza. And then it gives us a table with the cost. So first thing I need to do is I need to figure out what are my options. If I go to Six Flags, what can I get? If I go to Hurricane Harbor, what can I get? So let's do that next. And notice I had to get a new page, but the same thing, I'm just zoomed in on just the table because that's really all I need. Now, let's go about setting up our thing. Now, I like to start with a smaller number of options. So my smaller number of options is tickets because it only has 2. So I'm going to look at my tickets first. So I'm going to put a T up here so I know I'm looking at tickets. And my tickets options are Six Flags or Hurricane Harbor. And I'm just going to abbreviate those. Now, the next thing I'm going to look at is my lunch combos. Okay, so what am I going to have for lunch? Well, my options at Six Flags are a chicken strip basket, a hamburger basket, or a pizza. Well, that goes to those 3. And then at Hurricane Harbor, I can get a chicken strip basket, a hamburger basket, or a pizza. Well, that was easy enough. How many options do I have when I go to these places? Or how many options do I have to choose from for my trip? On these, if I only go these 2 places, then I have 6 outcomes or 6 options to choose from. Okay, that's the same thing we'd been doing, but now we're going to carry it one step further because notice, it now gives me prices. So let's see how that'll affect our choices. Now, I had to erase my stuff because I ran out of room, but you should have room right beside it to write things. If not, just scoot down a little bit and you will. So my options were Six Flags and a chicken strip basket. So if I went to Six Flags and got a chicken strip basket, well, the tickets at Six Flags cost $43 and the chicken strip basket cost $9. Well, 43 plus 9 equals 52. So that option would cost me $52. My next one, Six Flags with hamburger basket. Six Flags was $43 plus the $7 for our hamburger basket gives me a total of $50. Then I had my Six Flags ticket plus a pizza, which gives me $43 plus $10 for the pizza cost me $53. So that's how much it would cost me at Six Flags. Now I have to do my Hurricane Harbor. So I have Hurricane Harbor with a chicken strip basket. That gives me the $37 for Hurricane Harbor plus the $9 for a chicken strip basket equals $46. Then I have a hamburger basket Hurricane Harbor with a hamburger basket gives me $37 plus the $7 for the hamburger basket gives me a grand total of $44. And last but not least, Hurricane Harbor with a pizza gives me $37 plus the $10 for a pizza which gives me, $47. So those are my costs. Now, let's look at the questions and use these amounts to answer our questions. Okay, so let's look at our questions. Now, I'm not going to have the tree diagram in front of me, but you will have it, so just look up at the top above. Okay, it says, if each of the options were thrown in a hat, what is the probability that a randomly selected destination will be Hurricane Harbor? If I look back, I know I had 6 outcomes, and of those 6 outcomes, 3 of them were for Hurricane Harbor. Now, I know that I cannot leave my fraction like that. I'm going to have to reduce it. And if I look at both of those, I will notice that 3 goes into both of them. So I have to divide both of these by 3. 3 divided by 3 is 1. And 6 divided by 3 is 2. So my fraction in simplest terms is 1/2. Next one. What is the probability that a person's trip will cost less than $45? So I'm going to make another fraction for this one. First, I know the 6 is going to go on bottom because I had 6 options. Let's look at my options. I had several of them that were over 45, but I only had one that was less than 45. So the number that's going to go on top is 1. But that cannot be reduced, so I don't have to change anything. Let's look at the last question. What is the probability that a person's trip will cost more than $50? Same thing as I've done on the others. The 6 is going to go on bottom because there's 6 options. But how many of them are more than 50? Well, I have one that's exactly 50. But is that more than 50? No. So I only have 2 that are more than 50. But I noticed that both of those are divisible by 2, so that means it can be reduced. So I'm going to divide both the top and the bottom by 2. 2 divided by 2 is 1, and 6 divided by 2 is 3. And so that's my answer. Easy peasy. Okay, this question is going to use the fundamental counting principle. Let's look at it. Jackie and her friends decided they want to buy a souvenir, and they can choose from either a t-shirt or a hat. How would this change the number of outcomes? Use the fundamental counting principle to explain your answer. Okay, so fundamental counting principle, it says I'm going to count how many options I have for each choice and then just multiply them together. So for tickets, I had how many options? I had 2. I had Six Flags and Hurricane Harbor. Then for my food, I had 3 options. I had a chicken strip basket, a hamburger, or a pizza. So that is 3. Well, then I multiply them together. So 2 times 3 is 6. But they're wanting to know what if they can now buy a souvenir and they have a t-shirt or a hat. So I would still have tickets, which was 2, food, which was 3, but now I have souvenirs, which is 2. So now I have to multiply these 3. So 2 times 3 is 6, and 6 times 2 is 12. So it would change mine to 12 outcomes.